Hello everyone and welcome along to our session this morning. Thank you so much for joining us. It's a pleasure to have you along. My name is Amy. It's great to meet all of you, and I'm here at Glasgow Science Centre today, and you're joining us for your live Meet the Expert session that's part of your Learning Lab Bodyworks programme. I really hope you've been enjoying the activities in class so far. So thanks for joining us for this live session. Our session today is going to be a lung dissection, and it's going to be done by my colleague Harriet, who we're about to meet very shortly. I have a few things to say about that. So we are going to be doing, like I say, a live lung dissection. We're going to be cutting open some lungs and taking a closer look. They will be sheep lungs, and they do come as a byproduct of the meat industry, which means that no sheep have been harmed specifically for this dissection. So they're a byproduct of the meat industry, because otherwise they would normally go in the bin. And we're using them today to take a closer look at what it looks like inside a set of lungs. But what that means is that you're going to be looking at some organs being cut open, and really that's not for everyone. So feel free as you go through our session this morning, if you're watching and you start to feel a wee bit queasy and you want to step outside, please go ahead and do that. Look away from the screen, whatever you need to do. If you don't want to be watching anymore, that is totally fine. The other thing I want to say is, as we go through our session today, I've got some questions that I've lined up for Harriet, and things we can ask her about the lungs as we go along, but I would love to be able to pass on your questions. So if you're watching the dissection and you think of a question, what you can do in your class is get someone to put that question on the YouTube chat box, send those questions in, or if you're not watching on YouTube and you're watching on our website, what you could do instead to submit your questions is tweet us. So if you have a Twitter account, you can tweet us at GSC1 with your questions, send them in, and we'll get as many questions asked as possible in the session. And with all of that said, I think it's time to meet Harriet and start to take a look at our lungs.
Hi, Amy, and hello to everyone watching from your classrooms. So here we have our pair of sheep's lungs to begin our dissection. So before we get into me cutting open these lungs and taking a good look inside, we have to have a think about what our lungs do and where they are in our bodies. So I'm going to ask everyone to use your lungs. I'm going to ask you to take a deep breath in. Hold it, and out again. So when you were taking a deep breath in, you might have felt air travel through your nose or mouth, and where it heads next is what we are going to look at as you felt your lungs inflate, as they are just here at the top of your chest, protected by your rib cage. So when we breathe in that air, we're breathing in oxygen from our atmosphere. Our bodies need oxygen in order to be able to release energy from the food that we eat. That air travels from our nose or mouth down into our trachea, which is essentially your windpipe. It's just a pipe that sits in your throat, and we have a trachea right here that we can cut into. Now, obviously, yours wouldn't be this short. This runs all the way up your throat, but we can just have a wee look at the trachea of this sheep to show you a little bit about the structure that it has. So if we go over to our lung camera very quickly, you might be able to see that I'm just kind of running my thumb along something that is inside the trachea that helps to give it its structure. You might see these kind of white sections here. Look a little bit almost like teeth, I think. This is cartilage. And what cartilage does is it helps to give a bit of structure and a bit of shape to our trachea. We need our trachea to be open. We need to have air travel through it. So if we were bending our necks and we were moving our heads, and that was causing our trachea to open and close because it didn't have anything giving it structure, that would not look very good for us. We wouldn't be able to breathe very well. So that cartilage, all it does is a firm but flexible material that our body produces. It's not stiff like bone. It actually helps to give your ears and your nose its shape. And what that does is basically it makes sure that our trachea can remain flexible so we can move our heads, but we can also keep it open and keep oxygen coming through that. I like to think kind of the trachea as the trunk of a tree. So the trunk of a tree splits off into two branches. And if we have a look at where I've cut down to in our trachea, there are two holes that look a little bit like nostrils in our trachea right at the bottom here. These are called our bronchi, and they are where we split off into our two lungs. So let's cut down the left lung and have a wee look at what is inside. Oof, there is a little bit of air still left in these lungs. I don't know if you can see. There's a little bit of froth coming out of them. That's just air bubbles that have remained inside the lungs. They've not been fully deflated. So I am just going to clear a little bit of that froth and air away for you so you can see what we have next. So from our branches of our lung tree, we have gone into the twigs, the bronchioles. So you can see instead of just a couple of those little holes, instead of two of those little holes, we now have several all the way down here. We have all of these airways in our lungs just to be able to increase the surface area inside of them to get as much oxygen as possible into our bloodstream. We want to have the most kind of bang for our buck, essentially, when it comes to our body. We want to be able to get the most out of as few resources as possible. So because of that, the bronchioles are not where the journey of oxygen stops in our body. It's going to go even further. We've gone from the trunk, the trachea, to the branches, the bronchi, to the twigs, the bronchioles, going all the way to the leaves, which is the alveoli, the very last part of the journey that it makes here. And you'll be able to see we've got this very spongy texture in our lungs, which surprised me the first time that I did a lung dissection. I always imagined our lungs like balloons that are just empty and they fill up with air and they push it back out again. But it's actually a lot more like a sponge. And in this spongy material is our alveoli. If you were to look at them through a microscope, they would look a little bit like bunches of grapes. And they're surrounded by really small blood vessels called capillaries. And when the oxygen that we've breathed in reaches our alveoli, that is when it's able to diffuse into our bloodstream, into those blood vessels called capillaries. And we're able to get oxygen all around our bodies, pumped through our blood by our heart. Now, your lungs have to keep breathing every single moment of your life. So they are working pretty hard. And they're not doing that by themselves. They actually have a muscle that helps them to do that. If we look at the back of our lungs, you can see that we have this really stiff, really strong muscle right here. I'm really pulling as hard as I can to be able to tear it, and I just can't manage. This is called the diaphragm. Now, the diaphragm is this very, very thin, almost like a membrane kind of a muscle, and it's made of the same kind of muscle that our heart is made out of. It's made out of cardiac muscle, which basically means it doesn't get tired like the other muscles do in our body. And it is a good thing that the diaphragm doesn't get tired because it has to expand and contract to be able to pull oxygen into our lungs in the first place. So there are quite a few organs that are working really, really hard to get the oxygen into our lungs, into our bloodstream, and around our body. So that shows you a little bit about our lung dissection. Amy, I think you said you had some questions for me.
Yeah, thank you so much, Harriet. It's super interesting to see inside actual lungs. Amazing. So my first question is, these are obviously sheep lungs, but how similar are these to human lungs?
So sheep lungs, obviously they have the same function. Essentially, sheep breathe oxygen just like us. So the function isn't too different from human lungs. As for size and shape, these might be slightly smaller than your average human lungs. An adult human's lungs might be about the size of a loaf of bread. They're actually quite big inside our bodies. But the most interesting difference between sheep's lungs and human lungs is if you have a wee look here, I have got 1, 2, 3 lobes on these lungs on this side. I've got another couple of lobes over here, about 3 as well on this side, maybe 4. So humans also have lobes on our lungs, these extra bits just here, but we don't have as many as a sheep does. And one of the reasons we think that might be is that animals like sheep are evolved to live at high altitudes. You might find a lot of sheep toting about the hills in the highlands, and having an extra lobe in their lungs allows for more surface area to be able to get the most oxygen out of an area where the oxygen might be quite thin in the air. It's not as oxygen rich. So they're really able to breathe and get as much oxygen at higher altitudes.
Wow, interesting. They're equipped for going on adventures. I like that. Nice. So, and my next question is a little bit more about people and some of the things that people do that might harm their lungs. So I'm wondering if you could tell us a bit about how smoking affects the lungs of a person.
So smoking can have some pretty nasty consequences for your lungs. I mean, anytime we put something that is not where it's meant to be inside our bodies tend not to react very well. So if you're breathing in anything else than oxygen and air, if you're breathing in smoke, for example, what it can do is inflame your airways. So things like the trachea can kind of start to swell up a little bit, and it can kind of constrict your breathing slightly. Your lungs and your respiratory system might start to produce more mucus as a response, which can lead to quite a nasty cough. And essentially, it means that your lung capacity, your ability to take in all of that oxygen, gets reduced slightly. So you might find yourself getting out of breath a lot quicker than you usually would.
Yeah, that just sounds really nasty, doesn't it? Just something you do not want to get into. Not fun at all. So I guess then, do you have any thoughts on how we can keep our lungs healthy? What sort of things should we do then?
Well, I mean, exercise is brilliant for our lungs. Obviously, we want to be able to use them, and, kind of increasing your lung capacity by doing exercise is fantastic. Obviously, avoiding things like smoking will do very well. And also, the thing is, our lungs aren't just affected by, do you smoke or do you not smoke? Do you exercise? Do you not exercise? They're affected by a lot of environmental factors around us. For example, living in a city, you might end up getting a bit of air pollution that could affect your lungs very slightly. So it's also important that we keep our air clean in order to keep our lungs healthy.
That makes sense. I have a slightly different question. You were showing us the lungs a second ago and talking about the number of lobes they have. Are the left and right lung exactly the same? Are there any differences apart from that?
So the right and left lungs, they are different. They are very slightly different, and you might be able to see on the pair of lungs that I have. Can you see how on the left-hand side, the lung is quite narrow and it's quite long? And on the right-hand side is a little bit wider and a little bit shorter. So essentially what this means, it doesn't mean that one lung works better than the other. It's just because they have different organ neighbors. Essentially, your left lung is quite thin. It doesn't want to take up as much space laterally because it has to share its space with the heart. Your heart sits directly in the center of your chest, but it's larger on the left-hand side. So that left lung is a little bit narrower. For our right lung, it's wider and it is shorter because directly underneath it is your liver. So essentially, everything in our bodies is kind of fit together like a jigsaw, and that can affect the shape and size of our lungs.
Interesting. I'm imagining they're all packed in there really tightly then, because there's a lot happening in your body, a lot of different organs. Interesting. Actually, this leads me on to my next question, which is, are there other organs that are part of this respiratory breathing system?
Yes, there absolutely are. And we've actually even talked about them already. So, for example, our nose and mouth are involved in our respiratory system. The air goes down the trachea, which is another one. And we also have that diaphragm as well, that muscle, which is really, really important to our respiratory system right here. So, everything that you use to breathe is involved in your respiratory system. They all work together.
Nice. That makes sense. Um, So I have a question. You were talking very briefly earlier about when you were surprised that lungs weren't just an empty bag when you opened them up. Could you describe for us what it actually feels like in your fingers to feel a set of lungs?
Well, these ones, like I said, there's still quite a bit of air left in them. And oh, this might be a bit of a yucky um, bit of a yucky description. Have you ever had popping candy?
Yes,
And
I
that feeling
have.
of it popping and dissolving on your mouth. That's what it feels like on my fingers for all these little
Mm,
bubbles. So that's what it feels like if you were like to kind of give it a little bit of a squeeze. Otherwise, it's almost like a slimy kitchen sponge. That's what it feels like a little bit. And for the cartilage, the trachea, it feels a little bit like one of those kind of plasticky tubes that, like, if they've got lots of rings and you can collapse it and you can expand it. That's kind of what it feels like to run your fingers along the trachea. So
like
yeah,
a
maybe not the best description if you've just had your breakfast, but
yeah.
that's what they
Thanks for
feel
that.
like. Yeah.
Yeah, I'll be thinking about that later when I'm doing my dishes and I've got a sponge in my hand. Thanks. This leads me on to my next question, which might also be a bit gross. What do they smell like?
Ooh, not great. They smell a little bit. If you imagine, maybe you were making a bolognese or something, and you took the mince out of the freezer and you left it on the counter to defrost, and then you forgot about it for about a day. It is kind of like a meaty smell, not like cooked meat. And I'm not suggesting anyone go sniffing raw meat to find out what it smells like, because it's not pleasant. Um, or if you walk past the butcher counter on a hot day, it smells a little bit like that. It was the first time I dissected lungs, actually. We had to learn, all of us together. We had a lot of the science communicators who work here at Glasgow Science Centre. We're all in the lab, all learning together. But we all had to have our own set of lungs. So we were sitting in a room, and I think it was like June or July, and it was like 20 degrees outside. And we had a box of 10 lungs just sat out, and the smell was quite overwhelming.
Oh, that doesn't sound great. That does not sound great. You'd be going sniffing some really nice things after that to cleanse your nose. Oh, well, thank you for that description. Hopefully no one knows what really warm left out meat smells like. It doesn't sound very appetizing. Um, what other organs have you dissected actually?
So I've dissected lungs. I've also dissected heart as well. So actually, sometimes when we get our lungs in, the heart is actually attached in this little section here. There's actually like a little compartment for the heart called the pericardium, because obviously all of that oxygen, all of that blood, has to get all around our bodies, and it has to be filled up with oxygen from our lungs. So the lungs and the heart are very, very close together. Dissecting a heart, I would say I find it's a lot trickier. There's a lot more going on inside the heart, with all the ventricles and the atriums and all of that stuff, all of the different entry points that you have. If you cut down a heart and you've cut into the wrong section, it can be difficult to find where you're meant to be again.
Yeah, sounds really interesting though. Amazing. Um, I guess I'm wondering actually, because you've done heart dissections, lung dissections. Can you tell us a bit more about what is the purpose of doing dissections? Why do we do them at all?
Yeah, so I mean, dissections have a really, really interesting history. But essentially, what dissections are meant to do is, how can we treat illnesses of the body that happen internally if we don't know what the function or what any of these organs look like? Essentially, it's a method of being able to discover what is inside the body and how we can best treat illnesses of different kinds of organs. Um, so essentially, yes, we also do lung dissections here for educational purposes, just like you're doing right now. You're sitting in your classroom and you're watching and you're learning more about the body. And that's essentially why we do dissections. It's all about learning. It's all about discovering more about ourselves and our bodies.
Yeah, absolutely. And just like I said earlier, if we weren't doing this dissection, then these lungs, we don't typically tend to eat a lot of lungs in this country. So they'd probably just end up in the bin anyway. So it's good that we can do this and educate people on how their lungs work. Amazing. My next question is, why do we cough? Because coughing is quite an interesting thing that I think happens, we do it throughout the day. Why is that?
Yeah, so coughing is an involuntary response to an irritation to your airways. If you've ever, been sat in a theater or in a cinema and it's a really, really quiet bit and you can feel a cough starting to happen, it's really difficult to stop it. And it's an involuntary reaction. And essentially, as we are going about our days, we may not be breathing in just air all of the time. There's things like dust, there's little particles in the air, and even those teeny, teeny, tiny particles can irritate our airways. So essentially, if there's a little particle of dust or something that gets into your trachea, that gets into your airways, into your respiratory system, all that does is the brain sends a message to the diaphragm and the muscles around your stomach to just contract and push up and get that out of your lungs, because we really don't want to take in anything that could damage them.
That makes sense. Our body's just got lots of different ways to protect itself, basically. It's ready to take on things that come at us all the time. How much air can your lungs actually hold? You said earlier that in your body they're a bit like a loaf of bread, but do you know how big they could get or how much air they could possibly hold?
Yes, so for our lungs, they can actually expand to be quite big. And all of that air, like I said, is held in these lots of different kinds of airways. It's actually about 2,400 kilometers of airways if you were to stretch out your lungs completely and make them flat and smooth. So we can hold about 6 liters of air inside our lungs. So imagine like a 2-liter bottle of juice. Imagine 3 of those. And that's how much air we can fit inside our lungs in an adult body.
Wow, that's a lot more than you would think. Um, Bodies are amazing. You can just do all sorts. 6 liters. That's a lot of juice. So I can imagine it's a lot of air. um, I have a question actually about asthma. So there are lots of different conditions that can affect our bodies, and asthma is quite a common one. Can you tell us a bit more about how asthma affects our lungs and our breathing?
Yes, so I can tell you a little bit about it. Essentially, what asthma does, the symptoms of it and the effects it has on your lungs, is your airways become inflamed, kind of similar to how we talked about smoking. So your airways become inflamed and it can sometimes cause them to constrict. And that is that kind of wheezing sensation that you sometimes have if you have asthma and you're feeling quite out of breath. Your body will also produce more mucus as well to kind of be able to soothe that a little bit, but that can also cause some issues in your airways as well. So essentially, it's just because everything is swelling slightly, it starts to constrict and it starts to get a little bit harder to breathe.
Yeah, I actually do have very mild asthma. And asthma is relatively common. Lots of people have inhalers to deal with it. Like I say, mine is really mild. I've never had an asthma attack. But when I take a puff of my inhaler, that just gives some relief and sort of releases that feeling because when it happens, and mine is a reaction to allergies like cats, when it happens, my chest just feels a bit tight and like I can't get in quite enough air. But it's just really interesting to know how it works and to understand what's happening inside your body. Um, Amazing. I have another question that's about something that hopefully no one has ever experienced before, but it does happen every so often. How does your body stop food from going into your lungs or other things from going into your lungs? How does that happen?
So you would think that it would be quite easy for food or water to get into your lungs because, of course, your esophagus, which is where all of the food and drink and water goes down, is actually very, very close to your trachea. They share the same house, your neck. And essentially, you have a flap of tissue that sits over your esophagus called your epiglottis that can move when we swallow. So essentially, it's like, imagine like a rail track, and you have a little switch to switch which rail that you're going on. That's kind of how I imagine it. Your epiglottis is kind of like that switch, saying like, this one's open now. Okay, this one's open now. And that just means that we're not accidentally inhaling our food all of the time. Of course, it can happen. It actually happened to me this morning as I was drinking my cup of tea. I inhaled a little bit of it by accident. And of course, that defensive response was enacted right away. My body started to cough to make sure that none of that water, none of that tea ended up inside my respiratory system in my lungs.
That is very lucky that our bodies are prepared for that, because I know that sometimes when I don't chew my food properly and I swallow a bit and it gets stuck, I start to panic and think, oh, it's gotten stuck. But it does tend to move whenever I do start to cough or I get a bit of food sort of stuck in there. I start to cough, and it's good we have that reflex system. But it's really good just to be prepared for that sort of situation. If you're thinking today, oh, what would I do if someone around me was coughing or choking on food? You could find out. So there's the Heimlich maneuver. You can go and figure out how to, or find out how to actually perform that on someone. It's just good to know these sort of first aid techniques that you can do on each other in this sort of situation. Harry, I actually have one last thing I would like to ask. I wonder, because the lungs are full of air, do they float at all? Would they float?
Amy, how would I know? And how would I show that if I hadn't prepared a bowl of water earlier today? This is my Blue Peter moment, and I'm not going to let anyone take it away from me. So our lungs actually do float, and I'm going to show you. I'm going to cut off a section. These ones actually might float very, very well because they are still absolutely full of air. So I've got quite a big chunk of lung right here. And if I pop it into the water, you can see that it absolutely does float in the water. It's buoyant. So you can see, even if I was to push it down to the bottom, it comes right back up again. If I give it a little squeeze, it starts to produce these micro bubbles of air that you might be able to see if you're looking really, really closely, or maybe I can just see them. But yes, our lungs do float.
That's amazing that they float, and I guess that's what helps us float a little bit in water if we're in the swimming pool. If we have our lungs full of air, that helps us to float. Amazing. Harriet, you've done so well. You've answered loads of my questions. Thank you so much. I think I've learned so much about lungs this morning, and I hope that everyone watching has as well. But we're actually coming to the end of our session. So, Harriet, thank you very, very much.
Thank you for having me.
Oh, no worries. It's been a pleasure. The last thing I want to say to everyone before we all head off and let you go on with the rest of your school day is, if you've enjoyed watching this lung dissection, the Science Centre actually has lots of really similar resources to this on one of our websites, which is scrolling along the screen right now. It's curiousAbout.glasgowsciencecentre.org. If you go onto that website, we have lots of resources that are just like this. There's some links to interactive resources as well, and just lots to explore about the human body, as well as our planet, and looking into the theme of innovation as well. So please go check it out. There's lots to see and do over there. But apart from that, we've come to the end of our session, everyone. So I just want to say thank you so much for joining us today and watching, and hopefully learning a bit about our lungs. Hopefully I'll get to see you all very soon at some point, maybe at the Science Centre. But until then, thank you so much, and I'll say goodbye.